Hello, how are y'all doing?
Pretty good.
This is where one of you answers, please, because otherwise I don't know if I am properly displaying my sound. Can y'all hear me?
Yeah, we can hear you.
At least one thumb up. Yes, excellent. So yeah, my name's Steve Rain. I think I should be displaying what looks like a canvas page for y'all. And I'm just going to trust that things are fine and that you will let me know if things aren't going the way I seem to be thinking. I'm going to just trust. That's hard sometimes, but I'm going to do it. So yeah, this is Stat 313, summer term, the last 313 ever at Cal Poly, and the last summer term that's on a nominally a quarter basis. I think officially we're doing semesters, but I don't know how they worked it, and that this is still the summer classes, according to the quarter calendar. So Stat 313, what I wanted you to know was a couple things before we start up. One of them is I will just be recording the classes on a regular basis, and at the end of the meeting, I mean, I set up Zoom that it automatically records everything. And then at the end of class, after sometimes it's like 15 minutes, sometimes it's like an hour or so, I will make a link to the uploaded class, or make a link to class, and so you could review it if you'd like to. We'll talk more about those videos later. And then the class has two parts to it. One of the parts is the synchronous part, which is being recorded. And so some students in the past, due to necessity, have on some days been unable to attend. And so they know, I'm having my wisdom teeth out fine. I will just watch the video later. The other part of the class is asynchronous, but it's still to some extent timed in that you will be working with some classmates on group activities. I called them lab activities that you will turn in before the beginning of the next class session if you want full credit. So there's something that I'll be asking you to do later today. And if you and your group of co-students, if you will, get it done, you will upload it or what you've done by a little bit before noon tomorrow, and then I'll click the link at some point in time and verify, yes, you did it. I'll give you full credit for the work. So that's one thing I wanted to sort of draw your attention to right away. The recordings to you will be doing some work asynchronously with your classmates. And that always raises a couple good questions. I think the syllabus is my attempt to answer quite a few of those. So I want to sort of click my way into the syllabus. And maybe I'll show you this as if I'm a student, and so that way you don't see, so that way I can display things the way you would approximately see them. Clicking my way into the syllabus, it should show you, here's about the way I'm imagining things will go things will go this term. Okay. Classes pretty much now, and it's 50 minutes a day, Monday through Thursday. The class has an in-person final exam. Okay. And so it's going to be in Baker on campus. If for whatever reason you're thinking, oh, there's no way I can make an in-person, talk to me. We can work it out, I'm sure. Oh, if you can find a proctor at your location, often those are at other colleges or universities. There's sometimes a fee that you have to pay to get someone to make sure that you take the test in an official way. But the bulk of you should be able to be on campus, and so that's a good. Number two is you can always send me email. Yay. Third thing is this link here, you just click and it should work fine for office hours. Right after class on Mondays, okay, and then right before my next class, I have got a 4 to 5 p.m. also, and so on Mondays and Wednesdays, it's going to be between the two classes, and on Tuesdays and Thursdays, it'll be before this class, okay, and then after the other one. Also, if for whatever reason you need to get hold of me, I'm trying to click the link here. I'm not doing it now. But yeah, you should be able to book a time within Calendly to sort of see me. And that's fine. You can even invite a friend who's in the class to come join you for any of your appointments. General information, that's the regular stuff that you should read. There's software that we'll be using to tackle the material in Stat 313. There's a link in Canvas to how to get that done. The book that I suggest is Graphene and Hales. You already have that available to you in some fashion. But you should get it before we finish up chapter 2. Before we move into chapter 3, you will need a copy of that book to go forward. Homeworks twice a week. Do them, turn them in. If it's a homework assignment on a Monday or a Tuesday, you turn it in on Wednesday by midnight. If it's assigned on a Wednesday or Thursday, you turn it in by Monday midnight. So you'll always have at least one class session when you can show up at class at the beginning of class, say, "Hey, I got a question." And I'll say, "Hey, what's your question?" And you'll tell me the question. We'll talk through aspects of the problem at hand. So you have time to ask the question and then multiple hours to get it reworked before you need to turn it in. We're going to have two separate Canvas-based exams, and one of them will be exam 1, where I'm saying turn it in by July 3. If you go down to in the Canvas, it says, but on July 1 is when it says exam 1. So I'm going to give you like 2 days to get it done. Exam 2, it's going to be July 13th, 14th, 15th is when it's given out, and then turn it in by midnight of July 17. So you're going to have like 2 days to get the exam done. Some of you will do it right promptly. That's great. Others of you will take a little while. Right before exams, I sort of noticed here that we're going to spend a whole day in class doing any questions off of the sample exams before you then go ahead and start. So I've booked a whole class session for each of the 2 midterms. And then for the final exam, also, we've got a full day, full class session for review before the in-class final. Okay. So let's go back to the top. The final is not just 12 to 1, but 12 to 2. If for whatever reason you got a 1 to 2 p.m. thing, talk to me. We'll figure it out. Things always seem to work out. Okay. What else? The 2 midterm exams, 1/6 of your grade for each of those. The final exam is 1/3 of your overall score. So this is sort of a test-heavy, summer-oriented class. Tests are sort of the easiest way to sort of get an assessment of how you're doing. Students usually find that for labs they get full credit on because simply doing them gets you full credit. Homework scores, the average tends to be like 85%. So you think mid to upper B is the typical homework score. Some students are scoring in the 90s on a regular basis. Others are a bit lower. But overall, people tend to do pretty well in this class in summer terms. I've got a tentative schedule for you on the second page of the syllabus. Really, I'm trying to say, here's about what we're going to do on any given day. Okay, today is sort of like introduction and administrative trivial matters, and then we're going to go into a review of something you should know, and then more review of something you should have seen in a prior class, and then something that most all of you would have seen in a prior class, and you probably saw that in a prior class, and to be honest, maybe that as well. And so for the first full week, it's stuff you've seen before. We'll move into one new idea before the exam, and it's not really a big idea, but it's a necessary idea for us to understand the material for the rest of the term. So the first exam is largely, do you know what you're doing? If you don't, you have opportunity to catch up. Want to mention this little symbol here. I don't even know what you call it, but it looks like this guy. And yeah, a week from today, I have a doctor's appointment right around the time of class. And so I will not be having class or office hours at the regular time slot between noon and 2. I'm sort of busy at the eye doctor. And that's not the kind where you can sort of reschedule easily. It's the kind of eye doctor who does surgery and stuff. So I'm not sort of adjusting that. I will, however, have a early class that day. And if you can't make it because you're busy, fine, we'll still record it. Heck, even if none of you are here, I'll still be recording me saying something. There will probably just be fewer questions. What else? So here's an approximate list of the topics we're going to go through on the day. One of the topics labeled partial F test, it sort of is buried in chapter 10, and I like to give it greater emphasis and cover it more thoroughly and earlier than chapter 10. And then similarly, the topic called logistic regression, most students in 313 really say, oh, that's cool. That's something I would rather learn about than another possible 313 topic. If you have someone who tells you, oh, yeah, you need to know about nested models, okay, or random effects models, let me know. And if enough of you do that, we'll change up that last class session of content from logistic regression to a fancier sort of design of experiments portion of material. Other things to read through, and I try to cross out some things that aren't really relevant because, to be honest, the exam is structured so that you'll have access to a T table or a Z table. But if on the final exam you'd like to bring one and you won't have access to a computer, possibly on the final exam, we'll talk more about that later. I'm thinking maybe we should go with computer for the final exam. You just have to bring your own. But still, if you want to print something else and bring it, that's fine. Also, for the final exam, yes, I should take off the strike through for that portion there. Because, yeah, literally, I will be encouraging you to bring a note sheet for the final exam. At this point in time, there's always like at least one question that one of you has about the administration or organization of material, and I can see the chat, but I don't always pay attention to it. But I would like to pause and see if any of you do have questions you'd like to ask before I move forward. Okay, I'm gonna go with that sounds like a no. But I will say that I'm also someone who appreciates it if students sort of interrupt, even if like 5 minutes have gone by and we're on a new topic and you're saying, but hold on, what about that thing? Just unmute and say, but hold on, what about that thing? So going a little bit deeper into Canvas, chapters 1 and 2 in our book, plus, if you will, chapter R, the revision chapter, you can download that there. The authors are providing that material. Chapters 3 and later, the authors do not allow me to give that to you, so you have to get a copy of the book somehow. If you want to know how to download and install the JMP software, if your past stat class did not use that software package, it's free to you as a Cal Poly student. This link here should give you information about how you could get that installed on your machine. If you, on this next link here, if you want to sort of follow along with what I do in class, the data are right there. And it's every so often I will bring an additional data set to class that I hadn't brought previously. And if I do, one that's not there, I will add it to that zipped folder and then rezip it and then re-upload it for you. And so you'll have access to all the current data. Here's a file that sometimes I use in class, right around the time we get to week 4 or so, week 4, okay, when we do the partial F test. So yeah, you'll have a direct link to it then. Maybe jumping over week 1 through 5 now. Here is a excuse me. Damn it. I need to change that. So I will change that later. There will be a live link available with exam 1 study material from past exam 1 from Stat 313 here. Same thing for exam 2 and for the final exam, and you'll be able to later click those links to get access to review questions, things that you should know, etc. Similarly, I try to make a link to all the homework solutions for problems where you do the problems and you turn in like this Wednesday you'll turn in something by midnight. By Thursday morning, I should have the answers built into into the Canvas assignment, but also I'll try and put a link right there as well. And then, damn it, okay, so I need to edit this because clearly this should be tabbed over one tab as with the rest of these. So sometimes with some of the labs, some students will request, well, could you upload some of the lab answers on Lab 4B? And I'll say, okay, tell me which questions. I will upload some answers that match for you to study from. Office hours, office hours, office hours, always via Zoom because we're doing that this term. You could click that link as long as it's like Monday at that time slot or say Wednesday at that time slot. I should be in that location. Or if I'm not able to be in office hours at those times, I will announce that in advance, probably via the announcements section. But also, I'll put it like right up top, any changes to our schedule right up top. So that way you'll be reminded, hold on, no, that 1 hour, we rescheduled it. Okay. Excuse me. If you want to look at what we've done some past terms, like 3 years ago or 2 years ago, when I did summer 313, the summer 313 from 2023 actually was a very good class. So I sort of click your way into that. And I tried, and it is now a playlist, and you could click your way. And depending on the day and the time, and I'll show you later where you can find that, you could just follow along with the right topic that we're covering. And so you shouldn't be without a video resource because the live ones from this term, as well as from 2023 or 2024, and in general, the 2023 class sessions are a little bit better than the 2024 class sessions, mostly because there were about three particular students who were really good about asking questions during the course of the material, which caused other students to ask additional questions. And so this more of a Q&A, back and forth thing. Okay. What else? Other things you could read. I'm going to pause now about anything on the first page other than right there. Any questions? So what I want to then jump into is what I'll do on a typical class session. I'll click my way into the first week. So like I'll start here and then I'll say, okay, and this week or this half of this week, I guess if we go back, you can really see that this is the first half that I'm calling A and B, and then in the second half of this week I'll call C and D. A and B, C and D so it repeats, except for week 5, for whatever reason, it's like A, B, and C lumped them together because review is a different day. So the first half of the first week, it's just review of stuff that we should know from past and the beginning for ANOVA. Within each week, you'll find perhaps in a slightly different format, but something like this. On Monday, here's the stuff in our reading that you would want to do if you're using our textbook. There are 2 recommended textbooks for the class. If you have a copy of the Stat 218 book, and about 2/3 of students in Stat 313 took Stat 218 preceding their enrollment in 313. And so if you have a copy of that, the 218 text, here's the reference, the link, the thing you could read or reread if you'd like. I'll usually build into, and I neglected to do that for today, it looks like, damn it. I will build in a link to the notes for the class for the day. And here's where I will be putting a link to today's lecture content, as well as what happened 3 years ago and what happened 2 years ago. And you can see that, it's a June and then a July, second half of summer, first half of summer. Okay. And so, yeah, you have 3 different options of what you would sort of watch if you're going to rewatch something and weren't here live. And then for the day today, we're going to sort of dive in on the lab activity. I'll click my way into that for the moment. And this is what I'm going to ask you to do later. Essentially, it's download this document And one of you will probably, using Google Docs or something comparable, share with the classmates in your group, and you guys get to figure that out. It usually works pretty smoothly. But you'll get into Zoom room or somehow reach out via text. I don't know. The upshot really is that when you do sort of work together, you're going to go through the questions in this document. And I'm just opening it up, and oh look, there's a question. It tells you to do something with GMP, and you're gonna question, and then you're gonna answer, hey, do you think these two means are different? And so you'll address the question nicely. Okay, I see the question in the chat. I'll get back to that in a second. But always I have a thing for you to download, a document that you'll then work with together. And then you'll do here's the data set. And then once you're feeling comfortable as group, you'll click the start the assignment, and that will give you a place where you could upload a PDF of your completed work. Okay, so getting back out of that, go back. The question was about, do the recommended textbook sections cover the same material? Basically, they cover the same material, but in a slightly different fashion. Most students with our textbook are initially like, it doesn't have enough equations. I want more equations. Uh, People probably feel comfortable with equations. Okay. But I chose it because it doesn't have them. It presents the concepts. I tend to do a bit more of equations than our textbook does. If you really like equations, the Ott and Longnecker text, and you could probably find a copy of that for free, even if it's a couple, like two editions ago. That's got much more in the equations. Typically, people more from an engineering background would say, okay, yeah, I'm mostly comfortable with that. The Ramsey and Schaefer book is a bit better than our book in that it goes through more topics. And if you're planning and heading to grad school, that's probably another book I would recommend getting a hold of besides our textbook. So Ramsey and Schaefer presents the material in a chatty way. Again, not so much equations, but it does use the same style as ours, but it covers the material a bit more deeply. Some additional info, but largely it's slightly different in terms of the style of the explanation. Okay. As for whether you read the textbook before or after class, you know what? You know you. I don't know you. I do find that students who say they benefit from reading the textbook before class, they often will have more and different questions. But students who say they usually learn better by going to class and then reading the textbook, and that was my style when I was in school, um, then they'll have maybe questions the next day, and that's okay too. And I'm not going to say what you should do. I'm going to say you should try perhaps reading the book before class in the section. And if you're like, I'm not so sure about this, and then the class clarifies things, okay, that's a win. And eventually, if that happens often enough, you might try saying, well, I'll just see what happens if I go to lecture first, and then try reading. You might find it works for you about as well. So do what works for you. That's really the key idea. Okay. Darn it, I wish I had uploaded the notes, but it's too late to do that right now. Sorry about that. Tuesday, we're going to do the process again, except for it will be a new topic, analysis of variance, and there's 2 past videos that you could watch. And if you're the sort that really liked what they call a flipped classroom sort of style of things. Yeah, literally watching the video in advance, and that's probably not a bad thing. And then you'll have some questions that you have that when I go over the same material, but in a slightly different way this term with you all, you'll have questions as we go. And then the lab usually is something that corresponds to what a student would do afterwards. But again, you should do it the way you want. You, with your groups, you'll do it when you want to. Okay. As long as you get this lab 1A done by tomorrow at noon, you're home free. The homework assignment, homework 1AB, A to correspond to Monday, B Tuesday. I'm clicking my way into that. There's a bunch of data sets, fish oil, grants, fish, beet data, dioecious trees. Well, let's look at the homework assignment. It looks as though, okay, true or false. So review stuff, okay. And then do what we called a t-test, like we're going to do in class today. Maybe with the Grants Finch Beak data, you'll do answer a question or a set of questions there, A through E. Then with the dioecious trees, you're going to do again parts 1 through 3, 4, 5. And then when we hit the material from Tuesday, analysis variance, there's the melons data set and the trees data again. And this is data where in chapter 1, you're going to see a set of problems called melons. Do those. Another set of problems called trees. Do those. Even though it's the same data set as before, it's new problems because it's a different method, as well as that some fatty acids and T-Rex sort of problems. Okay, so I think so far I've got a couple questions via chat, but unmuting is also good for me. Any questions about sort of the nature of the first week and what we should be doing?
Just
Okay,
just
so
to
I want
double
to sort of
check.
dive right into the content. And again, it's Monday, so we're going to do a review of stuff that you should know from the past. And when I say should, that's a strong word. Stuff that if you're enrolled in this class with the prerequisites, you will have seen previously. And the word should know, you know what? It's a summer term. We're going fast. I have confidence that if you don't just remember the material, like, oh, I remember the name, you're gonna be comfortable. And if you remember the name t-test, but it's been 3 years, you passed it once. You're gonna do fine. It's just that it might take a little bit of effort to do the catch up again. The full of the first week and then the first class session of week 2, we're getting up to speed. So I'm going to sort of make this, well, move it over here and get into the material for the day today. Stat 313, t-test and confidence interval. Any questions about anything before I move forward? Okay, I'm going to call that a nope. And the real thing that we're doing in our review of the t-test is saying, I remember there's a way of tackling a question about two population means and finding out whether they're literally the same or not. That sounds like a t-test. Or finding how different the means are. That sounds like a confidence interval. I like to start with sometimes what I will term a box model. Hey, I can circle a thing. Yay, I did a thing. Let me sort of sketch out the box model for you. If you've got two populations out there, I'll call one population 1 and another one called population 2. And there's a distribution of values in population 1. And I'm drawing sort of like a histogram of sorts. And the one I'm drawing isn't necessarily, what is reflecting reality. I'm just trying to emphasize that the populations don't necessarily need to be normal in shape. And you could be thinking about, because we're going to do an example later on, population 1 could correspond to vanilla, and population 2 could be called chocolate. And we're sampling ice creams. And I want to know really whether ice creams that are labeled V are different on average in calories than ice creams labeled C. Or perhaps I might want to know how much higher are the chocolate ice cream calories than the vanilla ice cream calories. I don't know everything about the two populations. There's a lot of vanillas out there in the world. I mean, shoot, it's next to impossible to get all the ice creams because There's millions and millions and millions of them, but I could take a sample of size N1 from population 1 and get Y bar 1, okay, the first group's mean, and the first group's standard deviation, S1. And let me adjust something. There we go. And I could take a sample of size N2 from population 2 and get Y bar for group 2 and S2, the standard deviation, from that second sample. So my box model is like I've got these two populations in these two separate locations. I'm going to sample separately from each of the two populations. A simple random sample or fair sample from each of the two populations will allow me to use the data and use the methods. I can always use the data, but I'll allow me to use the methods that we have and feel good about that. Okay. What I try to do as we go along is I try to like take a quick screenshot. Okay, I got a screenshot, good, and I'm gonna then clear that and then show you how I could do this inside of JMP. So where do we go? Right there. Inside JMP, I usually have the data, and again, if you're following along at home and have already installed JMP, you could just click on where it says ice cream, like I just did, and it should open up that ice cream data set. You can see it's like bouncing around the JMP Student Edition version 19. And I see now, maybe I don't need all this. I could see information about my vanillas and my chocolates. And literally, these are data that were collected in major market grocery stores in 1993. So Breyer's vanilla, I don't know what store it was sampled at, but it's 150 calories. Okay. And if we go down to Publix premium vanilla, Publix is a Florida-based grocery store chain, 160 calories. If we went to Bluebell, that's a chocolate, Bluebell chocolate, 170 calories, and that's a Texas-based ice cream company. And so what we could do is like see what we think. Now I suggest here in the notes that we could use analyze fit y by x as a way of trying to tackle the data. Let's go up to analyze fit y by x. And we're going to see in weeks 1 and even through Monday of week 2, fit y by x is the way we do most of the things we're going to do. Okay. And I'm just asking the question, tell me about the number of calories separately for each of the flavor categories. I've got two separate groups. I got the V's and the F's. Flavor category tells me which group you're in. And then there's the number of calories, and that tells me what I want to know about. Calories grouped by flavor category. X as a factor, which of the two flavors, vanilla or chocolate, how do calories differ? I click OK. And what I see shown here is this graph. I don't know what you want to call it, a violin graph. You could call it a dot plot. I'm saying I see vanillas and chocolates. You could, if you want to, under display options, you could go down to this and say, I want box plots too. If box plots help you think through things, you could turn those on. Fine, yay. I don't feel the need to have the box plots, but if I do turn on things like means and standard deviations, I know for each group information about the mean and the standard deviation. 17 chocolates, mean of 175 calories per half cup serving, standard deviation of 44. For the vanillas, I got 18 of them, 166 calories per half cup serving with a standard deviation of 37. I'm clearly rounding a little bit when I say it out loud, but you know what I mean. You know what I mean? So we're talking about the mean. That was funny. Okay, so with summer classes that are via Zoom, it just doesn't work the same way as when I'm watching your faces in person in a classroom. Sorry if you didn't appreciate that. And if you did, well, it's still better in person. Okay, so you get what you get. Okay. So we have the sort of information that we said we would get, things like the sample size, the mean, and the standard deviation for each of the two groups that we're comparing. That's like what we talked about in our box model. So getting back into the flow of things, really what we can do with the data is say, let's just look at the data separately. And I'm noticing I did my two separate confidence intervals here. And it looks as though they sort of tell me I'm sorry, I apologize. Those are the box plots. You see the lower and the upper confidence interval, but those could also be displayed under display options. I can go and show you the mean confidence interval. Not necessary, but it tells me in this green range here, that's where the chocolate mean is likely to lie. The mean of the population, if you will, mu, the mean of the population I'm sampling from, which is different from the sample mean. Our chocolate sample mean in 174, probably the population mean, the chocolates worldwide. We're 95% sure that they have a calorie count in the 152 to 197 range. That's 152 to 197. For vanilla, it's 147 to 184. It's a little bit lower, that range. But those two ranges overlap. And so the question is, how much higher is the chocolate mean than the vanilla mean? I could look and say these two confidence intervals overlap, and so I'm going to say I'm not sure that there is a difference. But to tackle the question, how much higher is the one mean than the other, requires a little bit of additional work. I literally can estimate an unknown population truth. Okay, and I would love to know about the unknown population of value with its own separate margin of error. So let's get back into our box model and it's right there. And yeah, let's just go ahead and draw the box model. The box model here that we've got population 1. And it's got a mean there, mu1, and population 2. And it's got mean mu2, mu2. And for my convenience, I'm going to call this one now chocolate and this one vanilla, even though earlier I had put them the other way. And 1 is the number of chocolates that we take. We get y bar for the chocolate, or y bar 1. S1 is the standard deviation of the chocolates. I've got y bar 2 for the vanillas and S2 for the vanillas. Okay. And I believe that y bar 1 is close to mu1. Y bar 2 should be close to mu2. And we even, obsessing here. Sorry, that's a horrible looking mu. Let's change it back to looking better. Mu2. And because y bar 1 is close to mu1 and y bar 2 is close to mu2, if we want to estimate mu1 minus mu2, literally how many more calories chocolate has in it than vanilla, we could estimate that with y bar 1 minus y bar for group 2. Tell me how much higher the one group is than the other? Well, if I tell you in the sample how much higher one group is than the other, then we are in a good shape to move forward. Any questions about the concept? Okay, so I'm going to clear that and then switch back into our document. Our estimate is with some error. Literally, y bar 1 isn't exactly mu1. Y bar 2 is not exactly mu2. And so because y bar 1 is not exactly mu1, my estimate of mu1 with y bar 1 will have some error in it. Similarly, y bar 2 will have some error in it as an estimate of mu2. And so the term standard error here is one where we say, how far off could we reasonably be? So it's a standard error, and notice the subscript, the standard error for y bar 1 minus y bar 2. Yeah, literally it's saying, how far off is y bar 1 from y bar 1 minus y bar 2 as an estimate of mu1 minus mu2? How far away is my estimate from the number I'm attempting to estimate? We can see here an equation, and shoot, summer term, blah, 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 not many hours, blah, blah, blah. I want to draw your attention to a couple key highlights and move forward. Notice that larger samples, N1 and N2, would reduce then the standard error. If everything else changed and N1 were to go up, then the overall standard error of our estimate is going to get lower. In other words, more precision with a larger sample size. Similarly, if N2 goes up in value and nothing else changes on the right-hand side of this equation, the standard error drops. More precision in our estimate of the difference of population means because our sample is now larger in size. So that sort of makes some sense. Another thing that would make some sense if you think about it is if there's more initial spread in population 1, we're going to have a sample standard deviation that's likely larger in value. And so more spread in the sample says less precision in our estimate of the difference of the population means. And again, this is a refer back to your past stat class where we tackled that topic. Larger S, less precision, larger N, more precision. Yay! Ultimately, this is a number that we could calculate. Okay, and this standard error tells us how close my estimate is to the number I'm trying to estimate. So we're all happy with that. How do we use that standard error? Well, within the context of a confidence interval, our estimate of the difference of the two population means, literally, our estimate of mu1 minus mu2 is y bar 1 minus y bar 2 plus or minus a margin of error. The margin of error has two parts to it. The first part is, I'll just say, how certain do you want to be of being right? And to be honest, we could talk about it at greater length if you'd like to, but I'm saying statisticians, we tend to go with 95% confidence intervals. We want to be 95% sure of being right. You can never be 100% sure of being right. And we find there's a balance between the level of confidence you want and the width of the confidence interval, the size, if you will, of your margin of error, the plus or minus number. And we found that at about 95% certain of being right, we're sort of happy that to go for 95 to 99% confidence interval, you have to get considerably wider confidence intervals. We don't like wider, we want narrower. But if we make it much narrower, we drop from 95 down to like 90 or 80% confidence very quickly. So let's stick with a relatively high level of confidence, 95%, and it will give us the ideal margin of error. Again, we'll talk in office hours if you'd like to about picking a different level of confidence. That's not often done, but it can reasonably be done. I always go with 95% confidence. And you might remember that then that value for t is approximately 2 if you have 95% confidence. So how confident do you want to be? 95%. That means your t value is about 2. Times that standard error, and that's a measure of precision that we have on the earlier screen. How far off is our estimate of y bar 1 minus y bar 2 from mu1 minus mu2? Literally, how far off are we going to be from where we want to be? Plus or minus 2 of those is our typical confidence interval. So let's go ahead and try that. And I'm going to sort of skip over this thing called good degrees of freedom because in a different term, we could talk at greater length. I'm just going to say the software will figure it out for you. but that is the degrees of freedom that it utilizes. Okay. If we were to compare, well, let's tell you about the data set. These are data on, I guess, the blackout. BLA, blackout. Okay, so it seems as though in this data set, we have a number of births per day in New York City on weekdays or on weekends. You could see some of these days are like Saturdays and Sundays, and they're weekend days, but Monday through Friday, they're labeled weekday. So there's two types of individuals out there, weekdays and weekends. Okay. What we did earlier, well, let's go ahead and do that again. Under Analyze Fit Y by X, how does the number of births per day differ by types of day, weekday versus weekend? I click OK. I see it looks like weekend have fewer births per day and weekdays have more births per day. Like before, if I turn on the means and standard deviations, I've got data on N, Y bar, and S for each weekdays and weekends. We did sort of a cut and paste. N, Y bar, and S, N, Y bar, and S for each of the two types of days. So we could calculate via the equation that we had, and let's show you with that equation. And boom, there we go. Working from these data here, the standard error for Y bar for weekdays, D, minus Y bar for weekend days, Y bar E, that's going to be equal to, then our equation says the root of S for group 1 weekdays squared over the number of weekdays, N, D, plus the number of weekend days squared, that's standard deviation, over the number of weekend days. So in my case here, that would be equal to the root of 22.1 squared over 19, plus then 27.0 squared over then 6. Okay, and that should be equal to 12.1. Now, depending on the term, the regular term, I would stop and pause and say, will someone confirm this with the calculator? Instead, I'm going to stop here and pause and say, do you want me to answer any questions? Or is this just an equation that you remember from the past and you feel comfortable with it? Or you're saying, hey, I remember that and I know I could relearn it. Okay, cool. So I'm going to claim that's 12.1. Yay! Math was achieved. Okay, so I'm going to clear that. And if you wanted to use the fancy degrees of freedom formula, it will tell you go ahead and do 7.3. I'm saying what I'm going to do is I'm just going to go ahead and use my method here. My difference of sample means, okay, 454.5 minus 377.3. The difference there is 72. Plus or minus t, well, that's always about 2 for 95% confidence. If you want to be picky, you could say we need to use degrees of freedom equal to 7 because that's what we're told to do. And if you use a t-table, and I'm not doing that right now, if you're using a t-table with 7 degrees of freedom and 95% confidence, your t-value would be 2.365. That's pretty close to 2. That's the number of standard errors you go up. And what is the standard error? 12.1. We would get 77 plus or minus 29. I'm going to round a little bit here. I'm going to say this is about like, well, 77 minus, well, that's okay. That's 50 to 105. 50 to 105 is my confidence interval. My confidence interval is about 50 to 105. I'm saying I'm 95% confident that uh, the number of bursts that you have more on weekdays than on weekends, I'm 95% sure that it is in the range 50 to 105. That's actually sort of cool. I could tell you that's in that likely range. And maybe move that around. Okay, so on my iPad, I cannot highlight this. I can try and underline to the best of my ability. And did I get it? Oh, darn it. So the place where I would want to highlight and do that is not visible. Okay, I could at least circle it that way. So 50 to 105. I'm 95% sure that we have 50 to 105 more bursts per day on weekdays than on weekends. Let's see that JMP, the software package, will do that for us for free. And then I'm going to be sort of finished for the day. Okay, so clear drawings. Boom. Okay, so within JMP, you might have noticed that in addition to means and standard deviations, literally, you could have turned on this thing called the t-test. Dude, just turn on the t-test. The t-test procedure gives you, among other things, well, weekend minus weekdays. That's sort of backwards from what we had planned on. But I guess if I tell you the number of bursts per day on weekend days minus the number of bursts per day on weekdays on average, it's the same thing as if I told you weekdays minus weekend days. It's just that we would change the sign because we're changing the order before, which is before the minus and then which is after. So I'm going to go with weekdays minus weekends. I've got 50 to 105 more bursts per day on weekdays than on weekends. I'm okay with that. I'm 95% sure of that. It seems as though we have a confidence interval confirmation. Literally, the software sort of confirms everything we just said we calculated. Okay, I apologize for running just a hair over. I'm going to say the lab for the day, and I'm going to get you set up for that in a second. The lab for the day walks you through the confidence interval as well as the hypothesis test. Let's dive in on the lab activity. What you're going to do, I'm going to drag this back over here, is you're going to be working in your lab groups. Again, you're going to sort of click your way into where it says lab one. One of you or more of you will download that document, share it with the others, so all 3, 4, or 5 of you can work together, okay, to achieve the goal. You type in the answers, you agree, you chat with them as you go, and then you upload by tomorrow. Just to let you know where you're at, inside the people section, you should be able to see who's in a group with who. And you have these 3 different lab groups under groups. Let's see if I got it here. Week 1 groups. So Chloe, Grace, and Funa. Week 1, group 2, Emma, Luke, and Oscar. And then week 1, group 3, we get Augustin, Isabella, and Nyla. So you know who you are. You can find each other. You can reach out to each other. I don't know how to best do this, but I'm willing to sort of sit here and hang out while y'all chat with each other, or in some fashion manage to get hold of the others in your group if they are present, so you can move forward. And if there's anyone who's not finding their group mates are in class right now, let me know, and I could move you into a different group, and then the others could be on their own. So I'm going to sit here and do nothing for a while, and then office hours should be starting in a few minutes. And so work it out. I'm going to shut it down in about 5, though. If you have any questions or need help with the groups, let me know sooner rather than later. Otherwise, yay, and we'll see you tomorrow, if not sooner.
Thank you. Appreciate it.
In office hours at 1:10.
Thank you.
Oh, can you hear me?
Yeah, I can hear you.
Were you saying something, Luke or Emma? Because it's
Yeah.
possible that maybe I'm not even hearing anything. Maybe I turn my volume all the way down.
Oops.
Can one of you say something?
Sure. Hello. Hi. Hello.
Hello? Can you hear us?
Okay. I am not sure that I'm hearing anything, but that's okay.
Um,
I would like to hear something. Could one of you try saying my name again? So it could be these earphones.
yeah.
Hello? Can you hear us? Are you hearing anything?
Okay, I am not hearing anything, so makes me troubled. Oh well.
Also, to Luke and Oscar, I'll put my number in the chat.
Okay, sounds good. Um, it's a what type of document is it? Like a
I
Word or something? We can just do
I
a shared Word, right?
yeah, the original one is Word, and then
Okay,
we'll
I'm gonna
upload it
turn
as
these
PDF.
off and just see if that gets different.
Okay, sounds good. I'll put my number in.
Sweet.
So now that I can hear you, I'm sorry about that. Is there anyone who doesn't have at least one other person in their group in class today for you to reach out to them?
I think I'm all right, but I don't
Cool,
know.
cool.
I don't I don't see anyone from my lab group attending class, but I found their emails, so I'll just reach out.
Okay, perfect. Sounds great.
All right.
Well, I'm going to shut this down in about 3 minutes, then pop over to office hours, and I might see some of you there if you wanted to show up. Otherwise, enjoy the rest of your day, and we'll see you tomorrow.
All right, sounds good. Thank you.
And my
Bye,
sound will
thank
be working
you.
tomorrow. Eee.
Yeah, good.